and welcome everybody to a new online event within the EMS webinar series. I am Ernesto Rodriguez, President of the Spanish Meteorological Society, and I will chair this event. In this occasion, we present some aspects of a topic which recurrently appears in the media as one of the most important consequences of the current anthropogenic climate change, the sea level rise. In particular, our speaker will focus on the adaptation aspects. We expect that it is of your interest. But before introducing our speaker today, let me recall some practical hints. The webinar is being recorded and will be published later on the EMS YouTube channel. It is not allowed to record this presentation and upload it to internet by attendance in the event. Please use the chat to write your questions, which will be answered at the end of the presentation. Vesna Juricic, President of the Croatian Meteorological Society, and also member of the working group behind these webinars, will organize, group, and read the questions on the chat. And now let me introduce you to our speaker today. Gonéri Le Cozannet is a researcher at the French Meteorological Survey since almost 20 years. His area of research is coastal impacts of sea level rise and adaptation. He has contributed to the last the IPCC report as a lead author, and it is also and he is also a member of the French Climate Change Committee. The title of his today's presentation is Adaptation, as you can read on the screen, Adaptation to Sea Level Rise Toward Transformations. Please, Gonéri, go ahead with your presentation.
Thank you, Ernesto. Thank you for your invitation, and thank you, everyone. So I'm going to talk about adaptation to sea level rise. Are we going toward transformation? And I start this presentation by illustrating this by a coastal town in Normandy on the English Channel, where you can see that the coast is actually protected against storm surge through a dike, through a device preventing the river to the water from the sea to enter into the river during high tides. And this is actually protected. So we are already adapting to sea level rise and coastal hazards in this type of environment and in many other cases of environment. But the point is, what will happen with ongoing sea level rise? And this is what my presentation is about. I'm working at the French Geological Survey, so BGRM, and I will start with explaining that first, coastal risks are already a major concern. They are a major concern because this impact, we can see impacts, large impacts during extreme events, like in France, the Xynthia storms that occurred in 2010 and which caused 50 people to die. They died actually in their houses because they could not escape out of their houses during the flood. But it also cost a lot of money. It cost 750 millions of euros of insured costs. So only the insured costs are here, and there are much more which is not included. Of course, these are extreme events, and they do not happen every year. However, the point is that with projected sea level rise, you expect this type of event to to occur more frequently. And from an average of approximately 60 to 100 million a year in France of expected insured damages, we could have an increase of these damages by a factor of 2 to 10 by 2050. So there is a lot of uncertainties around this, and this is because coastal impact models have limitations. So we are in a situation where coastal risks are already a major concern, and on the top of that, we have sea level rise. And here you can see what the key elements from the sixth assessment report regarding sea level rise. So you can see this curve. In black, you have the observation. Sea levels have risen by approximately 22 centimeters since the beginning of the 20th century. So more than 1 century ago. Sea level are accelerating. It was 2 millimeters per year by the end of the last century, and it's now around 4 millimeters per year. And it will continue to accelerate, especially with larger, for larger global warming levels. So what you see here are projections corresponding to a very optimistic scenario where we achieve the target of the Paris Agreement. So we stabilize climate change at about below 2 degrees. So these are the curves in blue, and you see that we cannot prevent further sea level rise, but we can prevent further acceleration by stabilizing the greenhouse gas, the climate change. So that means reaching net zero in terms of emissions. But for higher global warming levels, so for example, 3 degrees of global warming in 2100, this is the SSP2/4.5, you reach approximately 60 to 80 centimeters of sea level rise by 2100. And for higher global warming levels, this is even more. The point is that sea level will continue to rise for centuries. They will continue to rise for centuries, and they will exceed meters. By, for example, here you have the projections by 2300, and for very optimistic scenarios, again, you have sea levels by 2300, which are between 50 centimeters and 3 meters, according to the latest IPCC report. But for other scenarios, where we do not achieve the target of the Paris Agreement, projections range from 2 meters to 7 meters, without excluding 15 meters. So what could happen? Why could we reach 15 meters? I have contributed to papers which say, okay, 15 meters may not be possible in 2300, but 12 meters might be possible. It is if we underestimate the contribution of Greenland and Antarctica to sea level rise. And this is a key point. So to have more than 7 meters in 2300, you need actually an acceleration of sea level rise, which is above the projected range, which you can see here. And that could be caused by accelerated melting from Greenland and Antarctica. So we have two very different ice sheets. One is Greenland, which is lying on a ground which is above sea level, and so it's very sensible to meteorological events, surface mass balance. And another one, which is Antarctica, with large part of Antarctica. What you see here is the topography, the bottom topography on which the ice sheet is lying. And in fact, you see that a large part of Antarctica, the ice sheet is in direct contact with the ocean. And the problem with Antarctica is not surface mass balance yet. The problem is that it is in contact of the ocean, and you observe retreat of this grounding line here because warmer sea waters are entering below the ice shelves and causing this melting and this retreat of the grounding line. So in practice, because we don't understand very well all these processes, we cannot exclude a scenario where sea level rise accelerate during the 21st century or beyond that. And that's why we have this possibility of meters of sea level rise happening much before than projected. Meters of sea level rise are many reasons of concern. The first one is that there are communities living in low-lying coastal areas. It's an existential threat for small island states. It's a concern for the cultural heritage. Think about Venice. For landfill and polluted soils, which are, for example, in estuaries. For unique coastal ecosystems like mangrove, like many others. And for the long-living infrastructure, think about power plants, for example. And because we cannot exclude a rapid melting of Antarctica, such adaptation challenges could occur much earlier and a high rate of sea level rise, in particular if these low likelihood, high impact outcomes associated with collapsing of ice sheets occurs. This is in the sixth assessment report, but if you look back in the past, EPA reports in the 80s, so in the US, were already raising this issue that potentially sea level will rise much quicker than we project using standard methods. There is regional variability in sea level rise, and you can see that, for example, using this sea level website, which is presenting the sea level data from the IPCC. This website has been developed by the NASA. And this variability is important. It's caused by the fact that ocean warming is not uniform at the scale of oceans. There is ocean dynamics. There is also gravitational changes due to the loss of mass at a large ice sheet and in glaciers. And all this means that there is regional variability. Yet, in practice, if you're interested in inhabited area, for the majority of inhabited coastal zones, projected climate-induced regional sea level changes are very close to the global average within a 20% uncertainty margin. So we have this challenge almost everywhere where people are living. And so we are speaking about adaptation here. We are speaking about adaptation, which means essentially reducing risks. And in the, let's say, the standard way of thinking about it is that reducing risks can mean either reducing the hazard, so flood maps like here, flooding like here. It can be avoiding being exposed to storms and sea level rise. That means removing, for example, buildings or avoiding to build in areas which are not natural today. Or it can be also reducing the vulnerability of buildings. So to illustrate what vulnerability of buildings can be, you have here two buildings which were affected by approximately the same wave forcing during the Xynthia storm in 2010. And you can see that one collapsed completely, the other one is still there, which means that they had different vulnerability. And one measure can consist in reducing vulnerability. It's called accommodation. This map, which is from the IPCC report in 2023, so the synthesis report of the sixth assessment report, you can see in gray people who are already exposed to sea level rise. So these are approximately 700,000 people in Europe, 60 million people in Asia. And by 2040, there will be additional people exposed to a centennial storm surge. Because, for two reasons. First, because sea level is rising. These are the dark orange people, and you see many of them in Europe. This will be approximately 300,000 additional people in Europe. But also because some people will settle in coastal zones. And for example, it is very critical in Asia. This means approximately 8 additional million people settling in low-lying coastal area. Because these areas are attractive, there is economic activity, etc. And what it means is that, especially in Asia and Africa, it is very important to have regulations, to have incentive, to avoid that we increase the exposure to sea level rise by creating new cities, new settlements in coastal area which are exposed to surge. And this is the first adaptation measures to avoid, to prevent new development in exposed coastal locations. For existing settlements, there are already many existing settlements in coastal areas. There are different solutions. And this solution can be classified, as you can see in the screen. In summary, you can imagine reducing the hazards, and that means protecting against coastal hazards, so like storm surges. That can be with dikes, with nourishing coastal dunes that prevent flooding to happen in low-lying areas behind dunes. You can imagine reducing vulnerability. It's called accommodation. So think about structural accommodation measures like having elevated houses or elevating ground in buildings. It can mean reducing exposure, and that's relocation. So you can relocate meetings. And for all these measures, it's possible to associate the measure with nature-based solutions. Of course, it's much easier when you are relocating, but that can be done. I'm going to go through these different adaptation methods in the coming slides. And first, remind that it's always possible to do nothing, but it doesn't happen on the ground for inhabited area. If we did nothing, the area which are in red here would be flooded at high tide. But because the North Sea is heavily protected by dikes and by dunes and by coastal estuarine barriers, of course, they are not flooded. So many of the areas which are exposed to sea level rise are protected already. And the challenge here is, of course, what is the maintenance and the upgrading of defenses? What are the costs of this? When should it be done? And what is the perception of implementing new protection measures? Because this is what will happen at some point. So protection, I went through it, but you have to realize that at some point, because we cannot avoid meters of sea level rise, if your strategy is to protect the coast, these protection measures will become increasingly massive as sea level rise will reach specific levels like 20 centimeters, 50 centimeters, 1 meter, etc., etc. And at some point, you need some heavy infrastructure like this one to protect coastal estuaries from being flooded at high tide. And this type of infrastructure, estuarine barriers, typically cost billions of euros, and they have adverse impact for ecosystem. This is something that happens in Southeast Asia city, where we have not only sea level rise due to global warming, but also coastal subsidence, because people are extracting groundwater from the ground, and this means that the soil is going down. So this is called subsidence, and that means that sea level in these cities can exceed 1 centimeters per year. So sea level rise can exceed 1 centimeter per year just because the ground is subsiding. And what we see, for example, here in Jakarta, this is a paper by Esteban and colleague, is that first people start to have some small dikes which protect to some extent until a certain sea level rise. But then you go to more massive protection measures, like, for example, land reclamations, like new highlands, like this type of things, and you need pumps to evacuate the sea level, to evacuate waters within this area. So from that type of pathway, you could imagine that in many cities, the pathway will be protecting whatever the costs. But in practice, we also see that there is relocation. There is relocation, and since a long time, actually. You can see that, for example, in this example, in a paper by Gibbons and Nichols, they were assessing what happened to a community in the beginning of the 20th century that actually lived an island within the Chesapeake Bay. And this island was left much before, almost 1 century before the last building collapsed, because the community could not have access to drink water, basically. This was the main motivation for leaving the island. But at the beginning of the 20th century, this community was more than hundreds of inhabitants, and they left a few tens of years after. So relocation is happening too. It's happening, and it's not always in response to hazards. It can be anticipating a bit these hazards. And this is an example here in southern France, where you can see a sand spit which is exposed to coastal hazards. And what is interesting here is that the project was actually to relocate that road, which is located here, which was exposed to storm. But relocating the road while creating some area which is, recreative area, so beaches, dunes, and so on. And so if you look at the cost of such project, it's very expensive. It's actually more expensive than protection, but it provides a lot of co-benefits, including for coastal ecosystems and for tourism. And so the main motivation for planned relocation in that case was, of course, to prevent and to adapt to sea level rise, but also because of the co-benefits, because of the benefits it brings for tourism and for ecosystems. That's interesting to think about. And this, the question that you can ask regarding relocation, like what are the costs? What is the perception of stakeholders? Of course, relocation is not popular at the first sight. You have to think about the larger co-benefits on the long term. What is the governance, and what is the economic model for relocation? Because at some point you need to buy some land. The perception at the first sight might be negative, and that happens in some cases, but it can evolve over time. And this is shown in a community which is in Northern America, in the Miquelon village in the Gulf of Saint Laurent, where our colleague Xenia Filipenko showed that at first, when people discovered that they probably have to relocate, they just rejected the studies that were raising the concern regarding the long-term sustainability of settling in this low-lying area. But at some point, some people living in this village actually thought that it makes more sense to invest in a higher area on hills located close to the village and progressively move the village to these hills rather than invest in area which will be flooded at some point. And so they moved from rejection to a project which is a locally led relocation project, and some people are very enthusiastic about it. So this means that we speak a lot about acceptability, acceptation. It's not an ambitious objective. Communities can take ownership of adaptation, and we should aim at finding adaptation measures which people actually support and not only accept. Reducing vulnerability, it can be, for example, raising grounds, raising elevating houses, or having waterproof doors. The costs are low to moderate. The feasibility depends on the context. For example, if you are exposed to waves, that's difficult. And here, this is within an estuary, not on the open coast. The effectiveness decreases with sea level rise. For example, with 2 meters of sea level rise, it's clear that it's not sufficient. And one challenge is the integration with other adaptation policies. Because, of course, reducing vulnerability of building is only one point within a broader adaptation pathway that consider higher amounts of sea level, which will happen at some point. And this is illustrated here based on a paper of Brown et al., who shows that coastal zones have evolved on the past, both because of climate change and other drivers like population, land use, water management. And on the short term, we have many political choices to be done. We can accommodate, reducing vulnerability. We can create setback zones. It might be forbidden to build in some specific area. But on the long term, you have just two options, relocation or protection. Both cost a lot of money. Both are difficult to organize and require strong governance. However, and in this paper, in this picture, which you can see, you realize that accommodation, reducing the vulnerability of buildings, is only a solution, a response for a few decades. And after that, of course, you have to choose between relocate or protect. But the advantage is it doesn't cost a lot of money, and you can postpone the final decision to later. One reason why sea level rise adaptation is urgent is that adaptation to sea level rise requires time. This is shown here in a figure from the IPCC report, which shows how much specific adaptation measures like protection barriers, elevating houses will last. So, for example, you can expect that elevating houses will be efficient for 30 years, and protect levees or barriers can be approximately between 50 and 100 years. But you need also to anticipate how much time you need to implement that option. And for example, for protection barrier, that can be between, let's say, it can be around 50 years. This is what we see when we start from scratch. Of course, when you have the governance, the finance well established, it can be quicker. And so that means that if we think about coastal adaptation to sea level rise, we should be already thinking about planning coastal adaptation measure, which will be in place in 2070. And in 2070, sea levels might be around 40, 50 centimeters above the levels of 2000. So which is quite a lot, actually. So that's why sea level is urgent, because coastal adaptation takes time. Another point to think about is coastal socio-ecosystems are highly vulnerable to climate change, and it's not only because of sea level rise, it's also because of drought, heat waves, salinization, eutrophication, hypoxia, acidification. And this creates a huge threat to coastal ecosystem like wetland, mangroves, corals, etc. And so while doing adaptation, it's interesting to think about nature-based solutions that actually reduce the risks, but also protect coastal ecosystems. And one very basic nature-based solution is actually to open the coastal wetland, because during a storm, what will happen is that if you have closed wetlands, the storm surge will be amplified within the estuary and it might flood anywhere, including in cities. If you open the wetland, then you will have the flood, which will be affect first the wetland, and probably the city can avoid being flooded. So this is one basic adaptation solution, which is very important. It also creates, let's say, more. It's good also for the sediment processes. There are others, like for example, nourishing beaches, protecting Posidonia banks from being removed because they protect from erosion. It can be, yes, recreating dunes, and to some extent, sun nourishment. It depends, of course, how it is done. It can have also some adverse effects to ecosystems. All these measures are actually assessed in the IPCC report, and they are assessed in terms of effectiveness and feasibility. Feasibility can be economic feasibility, technical feasibility, and so on. I will not go into the details, but it's just to say that the adaptation measures that I mentioned before, they are really a research topic where we are looking for papers and where there are many papers assessing feasibility and effectiveness. And another dimension of evaluation is what are the co-benefits and trade-offs. Because we see that people don't relocate only because of sea level rise. Relocate because they have some interest to do that, either because of tourism, because of co-benefits for the environment, and so on. And so we have to assess these co-benefits, and they are assessed against the Sustainable Development Goal. That was just a methodological point about how we assess scientifically these adaptation measures. But on the long term, what is important is that adaptation, it involves making political choices. We have basically two choices. We can implement incremental adaptation, addressing every problem one after the other, and maybe we will fail meeting the Paris Agreement because we know incremental adaptation has not worked very well so far, and we will not achieve the Sustainable Development Goals. And this is a word that you see on the left-hand side of the figure. Or we can think about transformational adaptation, achieving the Sustainable Development Goals, including on climate and biodiversity. And in coastal zones, this means considering nature-based solution, considering relocation projects, but also accommodation project, protection project, where you consider biodiversity. You create space for ecosystems and biodiversity. And so if you think about it, then adaptation becomes an opportunity. It can be an opportunity to recreate more resilient coastal environments and ecosystems. Transformational adaptation, of course, it's something very conceptual, difficult to explain, but in practice, scientists say there are three actually features of transformational adaptation. It should be a system-wide change, so not only a very small estuary, but something bigger. It should be quick, and it should be an in-depth change, meaning that it involves a lot of stakeholders from national to local and across many sectors. And so you have three strategies to initiate transformational adaptation. The first one is big plans and big projects. The second one is to change the rules. So for example, with governments, changing the rules, you have to be strong because you have to make sure that the rules are applied, enforced, and that they are progressively more strict so that you actually make some progress. And in many cases, we see that it's difficult to do. And there are small wins. Small wins are local experiments, which at some point you create a network of small-scale experiments that work, where people see co-benefits, and then you try to upscale and become a system-wide change. And this is, for example, what the Coastal Conservation Agency in France is doing with that type of nature restoration project, soft adaptation approaches. So to conclude, the future of coastal zones, it depends on immediate actions, mitigation of climate change, adaptation to committed risks, because we know sea levels are going to rise for centuries, And we see that transformation cannot be avoided. They will be very important. Those costs will be transformed by sea level rise, but they offer an opportunity, which is to better manage coastal ecosystem and to offer opportunities to these ecosystems. If we think about the status of climate action today in Europe, in France, in many other countries, we see that we are at a very low point. But we have, I think, to think that Europe can lead again on climate action. And that's a political choice. Do we rely on facts, science, the rule of law, health, well-being, and sustainability are the objectives for us? Or do we focus on preserving short-term vested interest, whatever the price? So, of course, when you ask this question this way, the response is very clear. And we have to think about this as a democratic challenge, I think, what we want to do in terms of adaptation. So I'd like to thank many of my colleagues who are here and who contributed to this work. Thank you very much for your attention.
Thank you, Gonéri, for this interesting talk, and now we'll move to the questions. Vesna, will you please read the questions? I invite to all participants to write your questions on the chat. Go ahead, Vesna.
Okay, thank you, Gonéri. This was really interesting. And the first question actually goes from Ernesto. He said, thank you very much for this very interesting talk. Although you have already discussed it, I would like to pose a bit provocative question. So imagine you are the policymaker managing a limited budget. What would you in general prioritize? Protecting current assets or planning for future relocation?
Yes. So in practice, we see that there is limited budget everywhere. In coastal cities that you see in Jakarta, in Southeast Asia, they are using a lot of budget to actually make heavy protection. The problem is the long-term legacy of this choice. So you are protecting now. It may not cost a lot because sea level have not risen yet by meters. But at some point, you know that if you start protecting now, it means that people will settle behind these defenses, behind these dikes, these barriers. And on the long term, you are locked in. You are locked in further protection. And this will cost a lot. So what we have to think about when making this type of decision is not only the cost now, but the costs in the future and the lock-ins that you're creating by choosing a particular option. And this is probably missing in many projects that I see, this long-term perspective. So that would be the point. And we see that there is a lot of problems with funding. In the Climate Change Committee in France, we see that one critical barrier to adaptation is funding, and we are looking for an economic model for relocation. This is governance. This is about having institutions who have the funding to buy land and create space for adaptation. And it's not only about coastal zones, it's also about inland wetlands, which are actually being more frequently flooded due to the heavy rainfall. So this is something I think any government concerned with adaptation should think about. How do I create institutions who have the capacity to buy land and to create the space that ecosystem and sediments need to provide coastal ecosystem services that support adaptation?
Thank you.
Yeah, and as you say, adaptation takes time, and at local level, municipalities worry about their mandatory 6 years, for instance, which are not consumed with the challenges that you describe. How to convince them to take this long-term threat seriously?
Yes. So first, I think it's important to realize that it's not. There are some small wins, and there are many municipalities that are acting to adapt to sea level rise. And the picture that you see here, close to there is another city which has decided to relocate a camping area because they realized on the long term it's more it creates more benefits than protecting. So there are many municipalities that are doing something. So how to convince to do something? There are many ways, of course. You can have a direct participation, and that's very important. Scientists discussing about what they know about sea level rise. There are regulations. We see that, for example, in Europe, we have many regulations about sea level rise with standard sea level guidance used in public policies like public policies on coastal risk prevention, on urbanization. And there are plans at national level, at local level, at regional levels that actually should consider that. We see that these plans, they need to be improved. They need to be better supported. And we see that many municipalities also do not really realize that. So what needs to be done? Probably a combination of creating the space to discuss these issues and of regulations, because of course it needs to be enforced at some point.
But then at what point does adaptation stop being viable and become a question of loss and damage? Who decides? Yes.
So that's a good point, because in practice there is a lot of confusion about this. So adaptation, you are more in the anticipation of future events, and you may relocate because you anticipate that there will be hazards, coastal hazards that will make it very difficult to settle in specific area. But at some point you may have losses and damages, and then you must relocate because there has been a huge flood or erosion, and the buildings, people cannot settle there anyway because it's not safe. And in many cases, we see that relocation happens after disasters, so after loss and damages have taken place. And I think it's important to realize that when we think about losses and damages, there are other challenges, like how do we compensate for the losses? Who actually owns the losses? Are the people who are exposed? Are these insurance companies? A reinsurance system, which probably needs to be backed by a public company like in Spain or France, because these areas are very difficult to insure by the private sector? Or do we need funds, public funds, to compensate? And what are the redistributive impacts of these mechanisms? Are we actually addressing the challenge of equity and justice? Meaning that, for example, are we redistributing money to people who actually are locked in and cannot do anything but relocate, but they don't have the means to do so? Or are we supporting people who actually own several houses, including one on coastal seas, and there maybe it's important to avoid using public money to compensate the damage of people who are very wealthy and knew that sea level rise was happening. So there are a lot of difficulties related to losses and damages compensation, including in the area of equity and justice.
Yeah, I already said something about insurance, and there is a comment and question. Does the insurance sector or reinsurance sector need to be more involved in the adaptation strategies? Or yes, maybe they are already.
So in practice, so I have contributed to an assessment of insurance in France, and the point was actually that today in France the public-private reinsurance system on natural disasters, the costs are increasing a lot because of climate change, but not because of flooding, because of drafts, which are creating shrinking and swelling of clays, damaging the houses. But that's billions of euros. And so there is an urgent measure, which is to refund the system, because otherwise it doesn't work. But on the long term, and it has been established by researchers since a long time, since the second or third IPCC report, you cannot you cannot expect insurance to compensate for losses and damages if there is no strong adaptation policy in parallel. So you need a strong adaptation policy, implementing the options that I discussed today, in order to have a viable insurance system that actually support that compensate for the losses and damages of people. And as I said, there is a discussion about what happens if this is something that is, let's say, fully in the private sector. And if it's fully in the private sector, at some point you have people who cannot pay for the insurance. You have some insurer who leave the area. So probably you need something which is a mix of private insurers and public and a public institution backing, acting as a public reinsurer of these private insurer, because then you can have a system which avoids these insurers to leave the high risk area.
Thank you.
And this is a topic which is discussed in Europe today.
Yeah. There are no more questions.
Okay, thank you. Let me thank to all participants for your attendance. The French Meteorological Society also for proposing this talk. The EMS webinar series were originally conceived as a way to enhance interaction between European meteorological societies. Finally, special thanks to our today speaker, Gonéri. And finally, let me recall you that the next webinar is scheduled for the 10th of June. The title will be Your Secret Advice for the EMS Annual Meeting. It will be a panel discussion moderated by Julia Thomas from the Karlsruhe Institute of Technology. And that's all for today. Thank you and see you at the next EMS webinar. Thank you.
Thank you very much.